Okay, so in preparation for moving on to relocatable object files, I'm going to need to be able to output like offsets of various bytes in the machine code that have been encoded. Um, but I don't have a way to actually track that right now. So in the encoder, I'm going to add labels and fixups, where labels are basically just going to be the recorded offset of the start of some instruction. And then the fixups are basically just going to be the recorded offsets, sizes, and end offsets of fix-up locations in the code. So for example, if we do a call, that will have like a 4-byte, let's say like rel32 address in there, or like displacement. So we need to know where that displacement starts, how big it is, if there's like an immediate on the end, like how far it is until the next instruction, so that we can do the add end in the relocation properly. So that's what I'm going to work on adding now. So we'll start with making some tests. We'll go to encoder test, and we'll just add a new one here. So this is just going to be a simple test for testing offsets. So we'll have an encoder. And the way that I thought I want this to work is that we can emit a slice of instructions. And for labels, we'll basically just match like a pseudo instruction, which will have like a pseudo operand encoding that I can switch on. And when we match it, we can just record the offset and just continue back to the start of the loop for the next instruction. So for example, with this, we'll do nil as the cached form. Then we'll have the pseudo mnemonic of label. This will be 0 size, and then we'll basically need to put in some operand here. And the operand will create the label in the encoder and associate it with an ID, which will just be like an index into a slice of labels. And it will also allow this to match like a pseudo instruction form. So we'll do enc L. So L will create like a label operand in the encoder, and it will basically just take a name. So this could be, for example, start. And this will record the offset, which will just be like the current number of bytes that have been encoded. So then we might have, for example, a call. Let's say it's dword, and here we want to like say, like if it was like a call to foo, we don't know what this is yet, so we still have to match like the correct form, which will be like a rel32 call. So we still need to pass in like an actual operand to match the correct form to output the correct bytes. But we need to basically associate this with some label ID, and we need to like record like a fixup site, which can be used later when we're outputting relocatable object files. So the operand that I'll pass into this will create with enc.f for fixup. So this might be, for example, call foo. We'll record like a kind of fixup. So for example, in elf, you would use like, let's say pl32 for like calls, and maybe jumps as well. Whereas you might use pc32 as like the initial like relocation type for just like rip relative addressing for like memory operands. So here we'll just say that this is fixup branch. And then we'll pass in an actual operand so that we can match the correct form still. So this will be like a rip relative. So it's relative to the IP register with a displacement of 0 because we don't know what it is yet. Then we'll do NA, NA, NA. Then we'll have like, let's say another label here. So this one can be a label foo. We'll do NA, NA, NA. And then let's just put in another instruction. We'll do ret. Okay, so this this label, or calling this function, will basically create a label in the encoder called _start, and it will associate it with it will associate it with an undefined offset to begin with, which I'll just say is -1. And then when we get to this instruction in the emit loop, we'll basically look up the ID of the label, which will just be stored on the operand. So the operand's value will just be the slice index for this label. And then we can set the offset to whatever the current output or the current length of the code is at that time. So this will create like a start label, which after the emission will basically be associated with the offset 0. Then we'll have this fixup here. This fixup should match the correct form for the call instruction, but we can notice that, for example, the rm operand is marked as a fixup. So we'll basically take this this operand here, and we'll just add an extra decorator to it, which will be like fixup. Then we can, check to say, is rm fixup or not. If it is, then we can basically use the value of the operand as the index into like a fixup slice, and we can record all of the stuff about the fixup using that ID or that index into that slice. And then this will basically just create another label ID. In this case, at this point, this label will be undefined, so it'll be -1 as the offset. And then as soon as we get down to here, this will basically create the same label ID, but when we go through the loop, it will actually define the label as having, I think in this case, it will be offset 5, because the call will be 1 opcode followed by 4 more bytes. So that should set foo as a label equal to the offset of 5. So to test this, we'll basically just take all of the labels and the fixups. So we should be able to look up like starts label. We'll call it start L. So this will be enc.labels, and to get the index, we can just look up the label ID, which will be _start. Then we should be able to look up the foo label as well. And we should be able to get the fixup. Let's call this fixup. Let's call this label. Okay. The fixup isn't going to be indexed by label ID though, because there could be lots of different fixups with the same label. But we know that this is the only fixup, so we'll just say this is fixup 0. So for the tests, we'll basically say that a label will have both a name and a kind. Or sorry, not a kind. It will have a label and a name and an offset. I guess we could omit the name because we can easily look up the name by looping over the map or something. But if I put the name on the struct, then it means I don't have to loop over a map every time. So we'll just say like want and got. So what we want here is start, and what we got will be start label.name. And if want does not equal got, we'll just say t.errorf want label name this got this. And then the offset for start will be 0, so this will be offset. And we'll change this to %v. Now we can do the same thing for the foo label as well. So this will be foo. Instead of start label, this is going to be foo label. And for this one, the offset should be 5, I think. Then we'll want to do the fixup. So the fixup won't actually have a name on it, but it will have like a label ID that it's associated with. So for this one, we can do enc.label ID foo, and this will be label ID. This is for the fixup. So what we want is fixup label ID. The other thing it will have is the fixup type, or the fixup kind. So this will be fixup branch is what we'll expect from this. We'll call it kind. So this will be fixup kind. Next, we'll also expect an offset. So the offset for this fixup will be that there's the call opcode, which is 1 byte. Then it will be just followed by the fixup, like the rel32 that we want to actually do the relocation for. So that will be at offset 1. So this will be offset. The size of it will be, it's rel32, so it should be 4 bytes in size. And we'll keep track of the end of the instruction, because that will give us the start of the next instruction, and we can use that difference between the offset and the end to get the add-end for the relocation. So in this case, the end will actually be at 5, the same as the foo label. So we'll say end is supposed to be 5. So I think if I mean, obviously, if I try and run these tests right now, it's not going to work because I've got a bunch of undefined stuff. So let's just go to mnemonics and we'll add in this sort of like pseudo one called label. And if we go to op-n, I already know that I'm going to have like a pseudo operand encodings. So this will be like op-n label. May as well add it to here. Okay. So we just need to go to the encoder now and add some fields to the encoder. So here we're going to have label IDs. This will just be a map of strings to ints. So this will be, for example, foo is ID 1, which will just mean that it's at index 1 in like the labels slice. So we'll need a labels slice as well, which will be a slice of all of the offsets for the labels. And then we'll need a bunch of fixups. And because we'll need to match on the label operand, and we'll need to be able to test whether an operand is a fixup or not, I'll have to add some stuff here. So fixups we don't need to actually match on, so I'll put that in here, but labels we do need to match on, so I'll put that in here. And actually if we go to forms and just do the like the pseudo label form. So a label has 0 width, the op-n that we get will be the label one, and there's no opcode for this. Okay, so let's go to the encoder. Fixups is actually going to need to be a fixup site, and actually labels needs an offset and a name, so this will be a label site. I'm just calling it site because I've already used label and fixup as like decorators, like for the info, bit fields. So if we define those things here, we've got type is label site. So this is going to be a name and an offset. Then we've got a fixup site as well. This will be a label ID. We'll need a kind, so let's just call this fixup kind, which we'll just put here. So this will be fixup branch. And let's also say we'll have fixup memrel. So this will be like a RIP relative one. So that will just help us with knowing which relocation type to assume to begin with. If it's branch, then we'll assume PL32 in ELF. And in ELF again, if it's memrel, we'll assume PC32 to begin with. Then we'll have size, and then we also need end. So we need a couple of functions on the encoder. So we'll do func encoder, we'll have L. So L needs a label name, and we're going to pass back an operand. So for this one, I guess we can just return operand, where we're going to have info is label, and the value, this will be uint64. This is going to be, let's say e.labelID, because that was another function that I said that I'd have. So this will basically create the label in the label IDs map if it doesn't exist, and it will return the value. And then I can use this value in the emit loop down here to look up the correct label site in the label slice of the encoder. I imagine that in the beginning of this as well, I should probably clear e.label IDs. And we should do something like e.labels equals e.labels, and just zero out the labels and the fixups. So this will give me a label operand, which should allow me to match on the label pseudo instruction. We'll also need, let's do label ID first. So we've got label ID. So this is going to return an int, which will be an index into the slice. So we'll say if, let's say ID OK, we'll say label IDs, we'll try and look it up. If it's OK, we'll return ID. If not, then we'll say that ID is basically the length of e.labels. Then e.labels equals e.labels. We're going to append to this with a label sites. So this will be name is just the name, and then the offset is undefined, so we'll say that -1. So that will allow us to distinguish between labels that should become, for example, symbols in the relocatable object file, and ones that are just currently undefined. They don't need to. They don't need to. Or yeah, they're ones that we don't know the offset of yet. So we would know whether to link them with like a section or not. Then we should be able to just return ID here, I think. So we check to see if, we actually need to populate this as well. So we need to say that label IDs here equals ID. Let's just put this here. Okay, so this should create the label, return the ID. That becomes the value of the operand that we can use in the emit loop. Then we also need to do a fixup. So the fixup will be a name. We'll have a kind, which is be the fixup kind, and then we'll have the operand. So what we'll do here is we'll say that o.info or equals fixup. So we'll keep the operand that we pass in so that we can match on the correct form. But we're just going to add fixup to it so that we can use that in the emit loop to record fixup information. So this will be, for example, return O. Then we'll need to know what the label ID is. So for this one, we'll basically just do e.label ID. and pass in name. We'll also have a fixup ID. This will just be the len of fixups. And then we'll want to say that o.value, we're going to completely replace value with the index of the fixup, which will be the fixup ID. So this will be uint64 fixup ID. And then we just return the operand. Oh, we actually also need to append a fixup as well. So this will be a fixup sites. This one will be label ID is label ID. Kind is kind. And yeah, I think that's all we need at this point, because we're always going to replace offset size and end anyway. So now in here, I should be able to match on the pseudo like label op-n. And then if I say, for example, e.labels, I can get the index of this from op1. I know that the label operand is always going to be op1, so we can say op1.value. Then that will basically, we'll just set the offset equal to the length of e.code, and then just continue to the next instruction. So let's just run this and let's just do the tests and see if there's anything else that's undefined right now. Oh, assignment to nil map. So yeah, label ID, we need to say that if e.label IDs equals nil, then we'll make the map string int. Okay, so invalid memory address or nil pointer dereference in emit. Okay, so it's not matching right now. Let's just print line the mnemonic. Yeah, so it's not matching label right now. So we've got label here with a width of 0. Oh, yeah, I need to put op1 in here, which should be a label. Okay, so now we get an index out of range. Yeah, okay, that's more what I expect. So we've got print. Let's just check I took the print out. Yep, I did. Okay, so when we do label, or when we do L, I guess this is. Yeah, so we've got labels is append. I would have thought that this should be okay though, because it's calling label ID, but it's saying that index 0 is out of range. Labels. Oh, this is because I'm clearing this already, isn't it? Okay, we'll just leave these out for now. Okay, so want fixup offset. So the labels are actually correct if I don't clear them out, which makes sense. I'll have to figure out where I want to clear out the labels though, because we don't want sort of like consecutive runs to necessarily be keeping everything. But I'll figure that out at a later time. Let's just get the fixups working first, and when it becomes a problem, I'll decide what to do. So the fixups are basically just going to be in disp here, because as far as I can think of, I'm basically just going to be targeting, at least to begin with, like small model code that's position independent. So I think I'm just going to be doing like rel32 like displacement sort of stuff. So we'll keep track of the offset here. And then we'll get to say that if, for example, rm is fixup, then we'll do e.fixups, we'll do rm.value is the index, and then we can say, for example, offset equals offset. The size is going to be the len of e.code at this point minus the offset, and the end will just be the current end, which will be the length of the code. But if there was an immediate after this, then we'll want to change end. We'll want to update it to push it out just a bit more. Okay, so that's labels and fixups. I'm wondering though what to do about like clearing things out. I suppose I could just have like another clear function for now that will do, you know, clear on e.label IDs, e.labels equals e.labels. And we'll do the same for fixups here. So this we'll just say that if you want to make sure stuff is clear, then for now we'll just call this clear function. It would have been nice to just automatically do it here, but we do actually need to keep the information. Yeah, we do need to keep the information before we emit and after we emit so that we can actually look stuff up. So I think I'll just do it this way for now.